Hi there guys, today I'd like to show you something fun made with the Arduino. And it's not going to be a thorough walkthrough or tutorial, it's just going to be a brief overview of a small project I have done over the Christmas. And I'm going to hold it up now so you can see it right here. I'll show you a screenshot or a picture of this up close in a minute. But basically what it is a Arduino Mega, some sensors, and a Wi-Fi module. It's the ESP module, and this one is called -05. And as soon as you power this, it's going to boot up. It's going to activate the sensors, activate the ESP module or Wi-Fi module, and then it's going to send data to a SQL server online and actually feed back the data so you can see it on a web server. And there already is services that provide this for you, but I'd like to run my own service. I want to run my own server, and I don't want to be dependent on some sort of free service. So this is purely made to basically test if I could upload data directly from my Arduino to a web server and then use it for something like a graph or whatever. So what we have on this is a quick overview here. We have a MV-teknik voltage regulator because this is able to be powered from batteries. We have a peer model, infrared sensor detecting motion. I have a DHT11, that's a humidity and temperature sensor. And of course I got the ESP module, and over here hidden away between the wires we have a LDR sensor measuring light. Up here I have a voltage meter and a small screen so I can see what's going on. I'm just going to hook it up to the computer so you can see what's going on. Right now I'm measuring voltage on, where am I measuring? On the lower rail. And you can see, it might be hard to see on the screen, but the monitor just turned on, or monitor, the small OLED. And it's displaying some stats. Yeah, we're not gonna worry about that right now. So it's running, and I can actually watch it right here and tell, okay, it's offline right now. And when this says online, it has connected to the Wi-Fi and has sent some data to the web server. So there we go. Let's take a look at the screenshot. I got a few. I got one with the blitz flash on the camera, as you can see. Here we go. And I got this one without the flash. I think we're going to use this one right now. So basically you can see we have the Arduino right here and a terrible mess of wires, but basically this rail down here is anything from, I believe it's 6 to 36 volts. I'm only using something between 6 or 12 volts input. Power runs into the LM7805 and up into this rail, which is a 5-volt rail. The 5-volt rail then runs into the Arduino. You can see right here there's no wire right now, but when I'm using external power source and no connection up here, this orange wire right here is going to be removed from the 5 volts and put into this one, which is voltage input. And then we have this green one, which powers the ESP module. That's 3.3 volts, and that basically takes care of all the power circuitry. Of course, each module requires power. The peer sensor down here requires 5 volts, so that's just hooked up to this rail. This one requires 5 volts, so you can see it's right there, hooked up to this rail as well. And LDR sensor is 5 volts as well, also hooked up to the same rail. The LDR sensor also has a 10K resistor right there between the ground and the sensor. You can see the sensor runs over to A0, that's the yellow one. All yellow wires are just sensor wires. All red or orange wires are power wires, blue or black are ground. Only exception is the green 3.3 right now. So we got sensor to analog 0. The peer sensor just runs over here. It basically just detects motion or not, so the input I get is 1 or 0, which is fine. My ESP module is connected through transmit and receive 1, not 0. You can use 0 down there, but 1. 0 is actually being used when I develop and debug the software, and the USB port is using the 0 connection, so that would just make things a bit strange if you start using the same. However, if you're using this on a Arduino Uno, you can use the 0, but then you won't have any serial feedback on your computer. On the Mega you have, at least you can see you have several channels you can use for feedback or hook up several transmit and sending modules. The monitor, OLED, is hooked up to 5 volt rail down here and is just using I2C communications protocols. The voltmeter is down here. It's this one, you can see it's a white wire right here and orange down here. That's just the measuring wire. The two others, the red and the black, are hooked up to this rail up here for 5 volts and ground just to power it. And then sometimes I take this wire out and I measure here and here just to see if I'm getting the correct voltages right now. So as you can see, right now I'm running 3.8 on this rail down here, but it doesn't really matter because there is nothing connected to this except this LM7805, and it does not run at this low voltage anyway. So there we go. That's the unit, and it works without this USB connection. You can just hook a battery into this rail down here. The gray wire you can see right here is the antenna for my ESP module. I used to have it down in that cutout you can see in the plastic, but it keeps falling out. And the antenna is very much needed. If you don't use the antenna, it won't be able to connect to your Wi-Fi. Here we have the same picture, and we used a flash, or I used a flash. And the funny thing is, we can see this flash effect on the output in a minute, but we can also see a bit more of the screen right there. It's not very easy to see, but hey. Let's take a look at the web server. So, here we have my web server. I'm going to zoom in a bit so you can better see. It's only showing the last 20 entries, and since it's offline right now, it's not sending anything. I got a time, I got a value from the LDR sensor, I got a humidity value, I got a temperature, and I got movement or no movement. Right now I have several entries, and you can see I have run it at several different times. If you notice, you can see it's usually when it's running, it's updating once per minute or once every 1.5 minutes. It's actually designed to send every 30 seconds, but it fails very often. So it actually succeeds every twice or third time. So that's fine enough for me for this purpose. If I wanted 100% success, I'd probably work on a more stable connection. All of this data can of course be turned into a graph, making things a bit more easy to see. And I found a graph solution online, a free one I just used for this purpose. And you can see the values right here. Notice this high spike right here. Guess what that is. You can see it was on the 27th of December 2015 at 12:18 Zulu time. Take a guess. Yeah, that's the flash from the picture when I took this picture. So luckily for me, I was able to take the picture just as it was reading reading the data, so that's actually quite funny. So this picture was taken exactly right here. So the data, well, don't mind these numbers down here. That's actually just the same as the tooltips. You can see it has a number, a date and time, but it's very hard to fit date and time into the spaces down here. But the red line is temperature, the green is humidity, blue line is movement. You can see no movement there and there and there, and light. So you can see there's no light and no movement. High temperature and high humidity. I'd say it's dark, nighttime, and my cat was here. Yeah, I'm sure he was laying on top of the entire thing or something like that. And you can see the temperature was just around 24 degrees Celsius. What's going on here? I'm not sure. And the same with the humidity spike right here. Why is the air suddenly so moist all of the sudden? Well, I can explain some of the spikes. If you take a look at the data, you can see I have a huge step right here. And when you take these huge steps, you're missing a lot of data. You can see from 11:23 it was 52, then at 19:03 it was 40. That's a huge jump. Well, it's not really that huge, but when you are doing it like a graph, it shows like a huge jump. And the same, you can see there's one right here. I suspect at this point I might have been breathing on it to increase the temperature to test if it was working. So I would breathe very heavily on the sensor, right? Okay. So that's the website. Sorry. Let's take a look at the code, the Arduino code first of all. I normally use the Arduino IDE, of course, as you can see. But I have copied it all over into MonoDevelop because it has this nice zoom feature, and I don't need to hide my Wi-Fi password, etc. So let's use the zoom feature. There we go. Let's run through the code. It's not that long, only 200 lines or so. Got a few libraries. The DHT, you don't need it, but it's very nice because it's using pre-calculated formulas to transform your measurement values from the sensor into something usable like temperature in Celsius and humidity in %. That's why I have it. GFX-H is needed to run the SD card. Sorry, not the SD card, the graphics on the small OLED display. And this is the OLED display specific library. The string APSSID is actually the Wi-Fi identifier, and this is the Wi-Fi password. Server code is when I upload to my server to prevent people from uploading on their own. I added a authentication code, and the code needs to be included in the data, or otherwise it won't work. So it's just protection. You don't really need it. So in fact, while we're going through this, I'm going to remove it so you can see how these things are connected. So we're removing the auth code there. Then we have the site. That's the domain where you enter the domain. I have my page. This is the link after the domain, excluding the domain. Let's write that. Excluding the domain to where you actually store the data on your server. Then we have things you want to add after your path to store. We'll get into that, but that's basically using a method called get when you're sending data to a HTTP server or TCP server. Alright. So I'm sending 4 values. I'm sending LDR, temp, humidity, and PIR, motion detection. The date, I'm still sending it, but I'm not using it. We'll get into that later. I just haven't removed it yet. Then we start the OLED, blah blah blah. We define our sensor pins, placeholders, global placeholders for values, time intervals because I have different wait times. I might change them accordingly. Initialize the DHT, and then we finally get to our setup. We set up our LDR pin, we set up our screen, and if I'm running developer mode, that's a boolean I got up here. There we go. Developer mode, it's true. If this is true, then I'm sending data or receiving data on the serial line to my PC. So by setting this to false, no data is being sent to the PC. So that's good. That's why we have it right here. We don't need to begin serial if we are running false, right? Serial 1 is to begin connection to the ESP module. And serial print, that's basically here we start to reset and initialize the ESP module. So we start out by connecting it here, and then we send a reset command instantly after. Excuse me. This one called vis or vice. It's called vis in Danish. That's a small thing I'm using to display things back on my PC. You can see it says void vis string what. This is Danish for what. If dev mode, meaning if dev mode is true, then print what. So you will see this throughout my code. It says vis something inside, meaning if the dev mode is true, then this will be printed back to the terminal. Long delay, we define delays up in the top. We begin our DHT measuring, and we initialize our main display. Don't mind these are something I added. We have our main loop. So if dev mode is true, then we would like to know what is the ESP communicating back to us. It might say error, it might say something else. Otherwise, we ignore it. Delay, we have a small delay. We start with a delay, that's a bit weird, but hey. Yeah, okay, that should be at the end of the loop, but hey, whatever. The loop delay. That's fine. We start by reading our sensor, motion sensor. We read our light sensor, and I actually feedback on that as well. If it's true, remember. We read our humidity and temperature in Celsius. And here we start the actual functionality of the program. If is online equals to false, meaning if the ESP module is not online, then we're going to set the display on the device to false, which actually means it shows as offline. Then we're going to display just the values. Then we're going to try to connect. We'll get to that in a minute. And after connecting, we're going to send the values. Otherwise, just display online, meaning if we already are online. So this will only run once or twice if it's possible. Oh my god. Yeah. Then this one will show true, and it will be online on the small display, and we get the values. This one is again sending the values just like this one to a web server. So let's go down to Main display first. Main display is just really what's going on the main screen. And you can see I'm taking 4 variables, I'm taking a boolean, I'm taking 3 integers. The boolean is down here, it's basically just to display online or offline. The values, sorry, the integers are basically just showing. You can see LDR, LDR value, humidity, humidity value, temperature, and over here we have temperature value. It's just giving you a live feedback. Then we have this one, ESP it's short for connection. And that's right here we have ESP and again I'm going to connect. We are already connected, we did that in the setup there, we did the reset as well, remember. Then we're going to send the mode to CV mode 1. Let's see. Excuse me. Yeah, it's really bad for my throat. We have this value, or library right here at GitHub. And you can see we have this CV, and you can just find the commands right here. And you can see CV mode 1 means station mode. So we are actually setting this to station mode 1. It's usually already at that. I'm just doing it again, just in case. In fact, you should actually run something like this right after to reset it, but we are not going to. Then I'm going to run the connection, string for bin, it means connect in Danish, and I'm running AT+CWJAP join access point. Then we're going to use the access point ID we got from the top right here, and the password as well right there. And then we're going to wait. Connecting. Previously I had you can see I have it right here, while serial, it would just stay and loop over these until it would give me a feedback from the ESP module. But I learned that sometimes it won't even give a feedback. Maybe it's because of bad voltages, I don't know. But I had a very large error marking, making it not so successful. So I decided to drop that loop and just ignore the ESP module's feedback and simply try to wait 8 seconds and then just send anyway. Sometimes it would just write OK. You can see if serial find OK, then it sends. If serial find fail, it stops and returns. Otherwise, it just goes back to the main loop and nothing has happened. So when it finds the OK value from the serial, that's the feedback from the ESP module, it's going to set the boolean to true, which is online. And when it's online, remember up here, it's just going to send the values to the server. So let's see how we are going to send the values. That's called ESP. Here we have the string get, and we're building the link of the entire server. So when we are entering data into a SQL server, you need to know some PHP first if you're using PHP. So let's hide our Arduino code just a minute. I'm going to pull it over here, and I'm going to grab some PHP code. And you basically need 2 files to store data. Of course, first of all, you need to set up a SQL server. And I'm going to show you something you should never do after 2015. I'm using MySQL, and that's something that's being outphased from PHP 5.5. So now you're going to use something called PDO, like this, PDO, or MySQLi. That's the new standards. But my server is running PHP 5.4, I believe. So I'm perfectly happy using old school PHP SQL commands. Basically, I first define, just like we did in the Arduino, I define my username, my password, my web address, and my database name. These 4 values. And then I have a function that's called connect, and that's it. This connect function has 2 commands. The first one is connect to database address, database username, database password, or die, which means if there's a fail, just stop. And then we have this one called select database, meaning once the connection has been made, we're going to open the database or make it available. But it's not going to run these things because they are inside a function. And as a C# or C+ developer, you should think of this as a void, a separate void, and it's not being called yet. It's just there. It's just standing there, not doing anything. Okay? No, we don't want to save. Let's close this one. Then we have this one called getData.php. And yeah, I'm just writing something. Hang on, just a minute. There we go. This one is actually the only thing you need. And still, remember, this is old SQL. After 2015, we are changing this to SQLi or PDO. Okay, enough. I'm just typing just testing, meaning if you enter this website, it will just show this and nothing else. Then it's going to ask for the previous file, the one we just saw, connection. And then it's going to call this command. What's happened is really it's going to take the entire file with all the connections and put it in front of here. We have just reduced this to 1 line. Then we're calling the function right away. And then we are getting these things from the menu. Meaning, let's get a browser. When I enter mydomain.com, I enter, you can see this one is called getData.php, question mark, and then we have something called LDR. LDR equals some value, and we have temp, TMP, which is stupid short for temperature, another temperature, and we have something called hum equals to another value, and sign PIR equals some value. This right here is actually what this is looking for. So you can see we have these 4 values, and there's an and sign, and in front of it all there's a question mark. So basically we have to build this string in our Arduino and put it onto this page. So that's what we're using the ESP module for. Then we have this, and you can see the PHP page is just taking this one and renaming it to this one. And down here we are building a query, which is something you do with your SQL databases, which is taking the data from the website and putting it into a database. So take this data and put it into this table at this position. This one data. You can see it's right here. We have these columns, table name, these columns, put in these values. So this value data gets in there. This value from here gets in there. This value is here, gets in there. That's basically what's going to happen. And this one is actually execute or run the entire function. This one up here is just like in Arduino. We are building the line first, and this one is running the line. That's all you need to know about PHP. Back to the Arduino code. So we have we're trying to build this line. You can see my domain, get data, PHP, etc. So, oops. I'm building it as a string. So we start out by calling it a besked, which is Danish for message, equals get. We want to type get first. Space. Then we want our domain. We enter the top. We want our page, get data. We want authentication. We removed that earlier. And date. So we get this date thing. Then we want our actual date value. That's this one right here. Then we're going to add sensor 1. Up here, our sensor 1 is called an LDR. So we are adding and LDR, that's this part right here, equals this part, and a value. And then we continue to build until the end. Then we end the message with http:/1.0/rn. Basically, it means it's sending a HTTP link signal. Yeah, it's hard to explain. And the RNs are just enter values for different systems, meaning it's actually doing this. So, okay. After we got this entire string, it should look something like this part right here. Then we need to send the string to the ESP module, but the ESP module needs to know how long is the string. Well, we're going to count the letters by just using this function called length. So besked message.length, and then we're sending a link message. This is another subvoid I wrote. ESP link takes the length, which is a number, and the message itself, that's the link. That's right here. So it gets the number and the message. Then we're going to connect to the website using a command called AT+CWJAP. So we can pull this one back and we can see down here we have chip start. Starts a connection as a client. Yep, that's what we want. And then we're going to say TCP and we're going to connect to our domain, not the entire link, just the domain at port 80. Okay. These are just relaying the commands once again, and we are waiting for something to happen. If we find an error, we just break and stop. Otherwise, we continue. If there is a delay on the error, we will never catch the error, and it will try to send even though we have the error, and this is why it's not succeeding every time, but it will try to send anyway. So I'm happy with that. Oops. There we go. Then we're going to send the link by... First we're going to use something called CIP send. So we're going to go back to this page and we're going to use this CIP send. And you can see the first thing it wants is the length of the data that we're going to send. So we got that from before. That's the count of the letters from the domain and the data we're sending. And we're just letting the ESP know we're sending maybe 90 letters now or soon. And then we're simply sending the link right after. That's it, because once you use this command, it will return something like this and just stand there idling. Everything you enter after this, it's going to try to relay to the site we just connected to by using CP start right here. And that's it. CP close, we're going to end the connection, and the loop is going to run from the beginning again. Yeah, let's quit that. That's all that is happening. It seems like a lot, but it's not so bad. Let's try something. I'm going to open my Arduino interface, power it up using my Mega, the one with the modules on. I'm going to open a sketch called AT relay. And I'm just going to make sure it's on the right port. Yeah, and I'm just going to upload it, overriding anything on there right now. So basically now I have my command module, and it's sending commands directly back and forth between my Arduino and the ESP module, and this is how you test if it works. So to test if there is a connection, you just type AT and it answers OK. If it says error, then you might be using the wrong baud rate, or you might be using the wrong line endings. And then you can basically just start here trying these commands, and you can see AT+CW list access points. And if this works, you can see, oh, I got 2 access points right here. I got one called rufflemouth3. I got one called HP print. That's the printer, right? And you can test the commands using inside the Arduino, like the reset. You can see it says OK, but please wait. And you get these error lines. Don't worry about them. That's just connection errors. It's fine. It's still working. You say it says system ready. You can see you get version of the current firmware. It's a 1.8902. Nice. And all of these commands, you can see if you get something like this error, wrong syntax, you say what's wrong? Oh, you need equal time. Yeah, we'll wake up after, so it's a sleep mode. And you can use all these functions, but some of them requires previous functions to be run. So something like AT+CWJAP mode. You can see, no, this is fun. I don't know why it's saying that. You can say question mark. It answers, well, I'm in mode 1 right now. Okay, that's nice. AT+CW mode equals 2. Then it changed the mode, and AT.CW mode question mark. I wrote move instead of mode. Nice, there we go. You can see it says error. Okay, that means we have to reset it. Reset and wait. And basically that's how you are going to send a learn how to use the ESP module. So you just sit here and experiment with how you're building these lines and texts. I know I might have made it a bit more complicated than it actually needs to be, but that's because I want this data on a website, and once I have it on a website, I actually have it inside a database. I can then also put it into pull the data out, and you can see I can set up different values. I can see this is my Unix timestamps, my LDR sensor values, my temperatures, my humidity, and my motion detection. And you can see I've just put them into Excel. I've extracted them from the website, and you can do all sorts of crazy things with this data. This one, you can go into this link, and this one is the one I'm actually using with the module you saw earlier in the video. Hope you enjoyed watching this, and if you have any questions, of course, try to write them in the comment section below, otherwise on Facebook, and I'll try to help. But a lot of the questions I'm receiving are often something like, I have connected something to my Arduino and it's not working. Why? Well, to be honest, I can't tell you why, because to debug or find the solution of something, you really need to measure the wires, see what's broken, what's not broken. Are you using the correct libraries? Are you using the correct code? It's extraordinary huge process to debug and find an error or function or something wrong. And one of the videos I get a lot of response on are the oscilloscope. I still have it right here, and I do occasionally use it. But people are using different monitors, they're using different versions of the Arduino IDE, which also has changed a lot since then. And a lot of libraries included in the code have changed, meaning they have changed the commands. Of course, usually you would think they make them better. Not always, but sometimes they do. But that also means that sometimes commands get deleted or removed because they are obsolete. And in order for me to update all my projects means I have to run all my projects. And I don't have room or data storage to be able to do that. So usually once my project is done, I disassemble them or give them away or something, and I don't have access to them anymore, and I don't store the code. So if there's any code involved and I put the code in, usually I put the code in a zip folder and I link it through Dropbox in the comment section below the YouTube video, and you can get the code there. I don't have it physically on my computer anymore, but that's basically it. So if you need help, please be very specific. Code, library, hardware, connections, as an absolute minimum for anyone to be able to debug any errors at all. Anyway, guys, thanks for watching. Comment, rate, subscribe, and I'll see you next time. Bye.